Okay, this video is about the extraction of aluminium, which you need to do by electrolysis. So let's, if we have a think about the extraction, well, aluminium oxide is aluminium ore basically, and that's got the formula Al2O3. So we need to remove the oxygen from the aluminium, we need to reduce it. Now, you cast your minds back to how iron oxide, right, you get iron from iron oxide. Well, you heat it up with carbon, and the carbon will remove the oxygen from the iron, and so you're going to get iron and carbon dioxide, and then to balance that you're going to have to do that. Okay, right, so that's achieved by heating carbon up with, heating iron oxide up with carbon in the form of coke, which is cheap, in a blast furnace, and that oxidation reduction occurs, a reaction occurs, you remove the oxygen from the iron. Now you can't do that with aluminium, because if you remember the reactivity series, you've got Al is more reactive than carbon, right? And then you've got zinc, and then you've got iron, and so on. So elements above carbon in the reactivity series can't be extracted. Right, if you heat aluminium oxide up with carbon, no reaction occurs, because the aluminium is more reactive. So that is why you need to use electrolysis, and that makes aluminium a much more expensive metal than iron is, because you need a lot of energy, a lot of electricity to extract it. Okay, so let's see how it is extracted. All right. So aluminium oxide, the first problem is, if you want to electrolyze it, you need to melt it, and its melting point is 2000 degrees C, really high, too high really for it to be viable. The energy costs would be too great, and the difficulties in maintaining those temperatures. But there's a way around that. If you add a substance called cryolite, cryolite is another aluminium compound. Its formula is actually, if you don't need to know, is Na3 Al(F6), so it's an ionic compound made up of sodium ions, aluminium ions, and fluoride ions. Okay, that's got a much lower melting point. That melts at about 700 degrees C. You melt that, and then if you add aluminium oxide to that, the aluminium oxide will dissolve in the cryolite. And the reason why it will dissolve is because, it will split up into the ions it's made up from. It's made up from Al3 plus ions and oxide ions, O2 minus ions. And they will mix with all of these ions, okay? And so you get, it's a good way of lowering the melting point, essentially from 2000 to 700 degrees C. That saves a lot of energy. Right, now let's see what happens at the electrodes. So aluminium ions are going to be, they are positively charged, Al3 plus. So in group, remember the aluminium's got the electronic structure of 283. So when it forms the aluminium ion, it gets a noble gas electronic configuration, loses those 3 electrons. Right, so they're going to be attracted towards the negative electrode. And the negative electrode, as we said before, is pumping out electrons. Now the aluminium doesn't want those electrons because it's a fairly reactive metal, but the voltage is such it has to accept it. So let's see what happens with the negative electrode. Right, aluminium 3 plus, it will accept 3 electrons from the electrode, and it will turn into aluminium metal. And of course the temperature at which that occurs means that the aluminium formed is going to be molten, okay, and that is actually heavier than the cryolite, and so any aluminium will drip down to the bottom, and you'll get a puddle of aluminium there at the bottom of the electrolysis cell. Okay, let's see what happens with the positive electrode then. Now the oxide ions are going to go there, And they've got the formula O2 minus. And we said before, the positive electrode is like a hoover, hoovering up electrons off those ions. So if you take electrons off them, they are going to turn into oxygen atoms. And of course, we know that oxygen atoms will always join up together to form O2. So I need to put electrons there. And of course, I need to balance that by putting that there. So that means there's a total of 4 electrons we're going to remove there. Okay, and you'll form oxygen. So aluminium is formed at the negative electrode. And if you look here, this is reduction, because the aluminium ions are gaining electrons. Just like we said when we were talking about the extraction of iron from its ore, we said that was reduction because you removed oxygen from it. So and you see here that whenever you get a metal from its ore, it's always reduction, because of course the metals are always positive ions, so they're going to gain electrons. Right. So the oxygen is being released at the positive electrode isn't the full story, because the temperature is very high, and of course this electrode is made out of graphite, which is carbon. Well, carbon and oxygen will react together at high temperature. So carbon reacts in the graphite electrode, reacts with oxygen generated almost immediately as it's formed, and the gas that is released is not actually oxygen, but it's carbon dioxide. And this, of course, will mean that this electrode, because it's reacting, it will wear away and it will need to be replaced. Okay, so that's how we extract aluminium, right? But just to show you, in the real, in the sort of industrial cell I've drawn here, what happens is this outer casing, this is the negative electrode, and it's graphite. So the aluminium is going to form there on this negative electrode. It will sink to the bottom. So I'm drawing here. This is liquid aluminium. And here's a little tap, and every now and again, the liquid aluminium can be tapped off. When that goes into there, the level will go down, and you can top that up by adding more aluminium oxide. Now, that also contains cryolite in there, but the cryolite doesn't react, so that stays put. And you just keep adding more aluminium. It's a continuous process. Don't let the thing cool down, because obviously it's going to take a lot of energy to heat it back up again to the 700 degrees C that is needed to melt the aluminium oxide in the cryolite. And the positive electrodes, well, you've got 3 different, they dip into the thing. I've got 3 of them there to increase the surface area. That's the positive electrode. And that is where you're going to get the CO2 being made. And that means that these electrodes are going to wear away. So I think what happens to them, they sort of they get shorter and shorter, and they get these are long sticks of graphite, and as they become shorter, they wear away. They are lowered down further into the cryolite and aluminium oxide mixture. It means you don't have to cool it down, just keep on lowering it as they get shorter. So that is how electrolysis is used to extract aluminium from its ore.